Welcome back, students, friends, and enthusiasts. So today we will discuss about a project. Since we have finished a timer IC, few projects, an explanation on timer IC, and also an operational amplifier we have used. So combining both, that is timer and operational amplifier, we'll do a small project, right? So this project name is Kitchen Security Alarm using LM358 and NE555 with MQ2 sensor. So here we are using one operational amplifier, one timer IC, and one sensor, that is, we call it as a gas sensor. Okay. So we will do a project. I will just explain you, then we'll go to the lab and we'll see the project. We'll go to the second slide now. Right. So this is the little description about the project, like you can call it as an abstract. What are the common causes of accidents in the kitchen? Why? Because the LPG, right? We have a cylinder, we use gas or some spark or some leakage. Mostly it will happen due to the accident happen due to those things only. So based on that, we have made this project. So I will just go to the next slide. You can go through the slides and you can read the things and all. And I will go to the next slide. Here you can see what is this is the schematic diagram basically. Okay, this is the schematic diagram. So we have used one MQ2 sensor in the beginning, and there is a power supply also. If you are using a power supply, since we have done it in the beginning classes, right? After diode and all, we have already done it. You can refer to those videos, how we did the power supply using bridge rectifiers. So if you are using a power supply, then you have to use a 7805, that is 7805 regulator IC, 5-volt regulator IC. But what in this case, I already have a power supply, that is regulated power supply of 5 volts. So I have skipped that part and I'm giving directly on the breadboard, directly 5 volts DC. So we'll start with first MQ2 sensor. First in the beginning, as you can see here, there is an MQ2 sensor on the here. Then it goes to the input, goes to pin number 3. That is the operational amplifier 358. Output from pin number, it is given to a transistor. Please remember here, they have shown a NPN transistor. You can, if you want to reverse the sound, because if the sound is continuous there on the buzzer, you can reverse this transistor or you can go for PNP transistor. Okay. Base will be same. Emitter collect, you have to check and you have to replace it. Okay. That we have already discussed in previous transistor classes. And the same output, that is collector of this, given to the timer IC. We are using monostable style timer IC. We can change the timings with the help of this capacitor, and this resistor. Okay. Of course, this resistor is also important. That is from pin number 2. Okay. This 1K resistor is also important, but 1 mega ohm resistor and these two capacitors are important for the timing purpose. The 3 number from the timer IC is given to the transistor, and the transistor will drive the relay. It's a very simple circuit. On the outside, I mean, on the other side of the relay, you can connect exhaust fan, or you can connect some motor cooling, cooling agent. If it is used in industry, you can use a cooling agent. So a lot of ideas can be generated with the help of this particular circuit diagram. Please remember, this is a simple diagram with the ICs. What ICs? 2 ICs, timer and operational amplifier. So I want that you should be knowing about this. If you want to try it, you can just do it. It is very cheap. You can do it. We can finish the project within 200 rupees also. Right. So this is not an embedded one because we are not using microcontroller in this. All right. So in this slide, we are just giving you the list of the parts, that is with the photographs and all, what are the parts required for this particular project, so that you get the complete idea. So we need 2 ICs, LM358, NE555. These are 2 ICs. Then we need one transistor 558, that is PNP transistor, one NPN transistor, and some LEDs, one diode, few resistors, few capacitor, one buzzer. Okay. And then if you need miscellaneous, you can check, you can get exhaust fan if required, that is to connect on the secondary side of the relay. And you require a sensor, that is MQ2 gas sensor. Okay. It's a smoke as well as gas sensor, and also a relay. Okay. So buzzer, relay, sensor, ICs, and small electronic part like resistor, capacitor, transistors. These things are necessary. Let's go directly to the, which is very simple. And here we have not used any embedded product or embedded boards. No microcontroller has been used. With just simple circuit, since we have done project with the help of your operational amplifier and your timer. Okay. So combining both together, that is operational amplifier. This is the operational amplifier IC, LM358, and this is timer IC. This is 555 IC. So combining this two circuits, two ICs, and combining a gas sensor, that is MQ2 gas sensor. Gas sensor, this is very important gas sensor. You can do a lot of project based on this. Why? Because it's a LPG gas sensor, butane or propane, methane, carbon monoxide, all type of sensing it will be doing. And apart from that, after this, it will trigger this particular relay. So you're suppose if we give the name to this project, right? Kitchen security alarm, like kitchen security alarm. In kitchen security, what happens if suppose in kitchen there is a leakage of gas or there is some smoke is coming, burn is coming, immediately this relay will trigger off your supply voltage. That is your main supply. It will just close it down, right? Automatically it will sense and it will shut down your power supply. At the same time, there we have used one buzzer also. You can see here this buzzer. So this buzzer, what it will do, it will continuously give you warning signal, like it will just buzz on, and you will come to know whether what is the wrong with the what is wrong with your kitchen light. Okay, so I will just give you a small demo first. Before that, I will just tell you what are the things we have used here. This is, you can see here, this is gas sensor, MQ2 gas sensor. Okay, this is a module, it's a sensor module, right? Okay, now this sensor, we have given one connection to 5 volts. This whole circuit is working on 5 volt. Please remember, supply is given, one power supply that's negative has been connected, and the input is given to this operational amplifier, that is 358 pin number 3. This is the pin number 3. On pin number 2, as we have seen in other operational amplifier, we have used one potentiometer, or we call it as a preset. It's a 10K value preset. This we have used the 10K value preset. One goes to ground, one goes to through a resistor. It will be going through 1K resistor. It will be going to the supply. The supply resistor I have connected here. You can see here. I'm just touching it here. This is the supply resistor, and one is going to pin number 2. So we can adjust this preset accordingly. Our sensitivity, we can adjust the sensitivity. Of course, there is one more preset on this. This here also on the sensor, you will have one more preset, which will be here. You can see here. This is the preset, but here also for this balancing this IC, we have used one preset over here. Okay, right. So for output, pin number 1 has been taken to given to pin base of the transistor. Okay, right. This transistor, about this transistor, I will tell you. In the circuit, it is given BC547, that is NPN transistor. Okay, but I have used a PNP transistor. Why? Because it is reversing the process. Because it is reversing the process. When a BC547 is used continuously, this buzzer is on, right? Buzzer is on. I want that when it senses the gas or smoke, then only the buzzer should be on. So I have changed the transistor to BC558, that is PNP transistor I've used. Okay, from there, the output has been given to this timer section. Timer, pin number 2. Right. Okay. So you can adjust the timing. How can you can adjust with the help of these 3 things? Okay. One, this resistor that is connected on pin number 7 to supply high value resistor. There is one more resistor in between pin number 2 and the supply. Right. I have used 10K resistor over here, and I have used a capacitor that is from pin number 6 and 7, which is joined together. You can see here pin number 6, this jumper over here. So it is joined together, and from there I have taken a capacitor. One end goes to ground. Okay, and the output from pin number 3. This is the pin number 3. Pin number 3 is given to an NPN transistor. This transistor we are considering, or we are taking for driving this particular relay. And output, I have for just for this purpose, I have corrected one LED in the output. Okay, so this is a relay, that is electromagnetic switch to drive this transistor. This IC will drive this output, that is the transistor, and transistor will drive this. And this particular IC will give you output, and this transistor will drive this your buzzer, as well as it will give signal to the input signal to this. And it all depends upon the gas and this thing. So let's test it. Okay. So I've given 5, I've connected 5 volts over here. You can see I've connected 5 volts, and I will just try to give, first I will try to give some gas. Let's see what happens. What happens with the, if I put the gas, so I have a lighter with me. I will just try to give burn the lighter. I'm not burning the lighter. I will just, what I will do is, which is very simple. And here we have not used any embedded product or embedded boards. No microcontroller has been used. With just simple circuit, since we have done project with the help of your operational amplifier and your timer. Okay. So combining both together, that is operational amplifier. This is the operational amplifier IC, LM358, and this is timer IC. This is 555 IC. So combining this two circuits, two ICs, and combining a gas sensor, that is MQ2 gas sensor. Gas sensor, this is very important gas sensor. You can do a lot of project based on this. Why? Because it's a LPG gas sensor, butane or propane, methane, carbon monoxide, all type of sensing it will be doing. And apart from that, after this, it will trigger this particular relay. So you're suppose if we give the name to this project, right? Kitchen security alarm, like kitchen security alarm. In kitchen security, what happens if suppose in kitchen there is a leakage of gas or there is some smoke is coming, burn is coming, immediately this relay will trigger off your supply voltage. That is your, I will just try to put a gas on it. Okay. So let's see what happens. Okay. So the gas has come, or the buzzer, you can see the buzzer sound is noise is there. Buzzer noise is there. I will just try to put a gas on it. Okay. So let's see. You check it once again. I will just try to show it to you. I'm putting gas on it. So you can see the buzzer has come up as well as this light has also come up. That is, the relay has switched on and this bulb has come, means the home electricity has cut. How it was there for say about 20 seconds. We can increase the time up to 1 minute, 2 minutes, or continuously depending upon 1, 2, and this 3 parts. Okay. Once again, I will tell you, these are the this resistor, which is coming from pin number 7, higher value, the resistor between pin number 2 and the supply, and this capacitor value. This capacitor value, what I have used it is 10 microfarad now. You can increase, or you decrease, means if you decrease the value, the timing will go down. Okay. And increase the value, the timing will be up. Like 30, if 20, then you want to make 30 minutes, 30 seconds, then you can increase this. So this 3 depends upon this. So there is a timer circuit. What timer we have used? Monostable. Okay, please remember monostable. We have already discussed in the previous videos about monostable. So we have used a monostable and a operational amplifier, and we have made this. So I have checked with the gas. Once again, I will try to show it to you. See, now the light has come. It will stay for some time. Automatically, it will switch off. I will show you with, right. So the gas effect has gone. So automatically it has stopped. Okay. Now I will show you with the smoke. Okay. Please remember, it is a smoke also. It will work. See, the smoke, I have put this thing also. So it is working. So these type of project, you should also try to do it. So how you will do it, this project, it's very, very simple. You can make it. First, I want that you should be doing all this type of project without microcontroller, right? You should get the confidence. So that is why I'm telling you, we are not using a microcontroller or embedded system board. So what you can give name to this project? What are the different type of project? What names you can give to this particular project? So your project name can be kitchen security alarm. Number 1, kitchen gas leakage and power cutoff alarm. Kitchen gas leakage and power cutoff alarm. Third, in industries, that is industrial security alarm for gas and chemical industries. Gas and chemical industries, they should have this type of security system where there is a leakage or burn or whatever it is, immediately the alarm should be there and the people should know that the things, the factory has to be vacated or this thing. So industry fire alarm, we can do it. We can name it as an industry fire alarm and smoke detector alarm. So this 5 I have told you: kitchen security alarm, kitchen gas leakage power cutoff alarm, industrial security alarm for gas and chemical industries, then industry fire alarm and smoke detector alarm. Okay. So using this, and if suppose if you don't want to use this, no sir, I don't want to use the gas alarm, I can use any other alarm, this thing. So security, gate security, you can make it by using this proximity sensor. Okay, this is the IR sensor. If you put your hands near to this, the proximity works. I have to just replace this part over here and I have to adjust this preset, that this particular preset, so that this IC voltage, that is pin number 2 and pin number 3, inverting voltage. I told you one is inverting and one is non-inverting. It will be balanced and you can use any of the sensor. So you can make many of the projects. Why I have shown you? Why? Because we have already finished the projects or the circuit with any 555 IC, that is timer and the operational amplifier. I hope you understand.